In this problem, it's given that alpha and beta are the solutions of the equation a cosine theta plus b sine theta equals to c. Using this fact, we have to prove that cosine alpha plus beta has this particular expression and cosine alpha minus beta is given by this particular expression. So let us begin. Now, before beginning, let's state what is the expansion of cosine alpha plus beta, because that's a standard formula. That's cosine alpha times cosine beta minus sine alpha times sine beta. And if we want to expand cosine of alpha minus beta, so that's equals to cosine alpha times cosine beta plus sine alpha times sine beta. Now our goal will be to find out the product cosine alpha cosine beta and the product sine alpha sine beta. For this, we're going to take the help of this particular equation. Now step number one, what we'll do, we'll take this equation, which is a times cosine theta plus b times sine theta. Now this is an equation, this is C. So this equation involves both cosine theta and sine theta. And the first step, what we'll do, we'll try to get rid of this sine theta. This is going to give us one quadratic equation in terms of cosine theta, and in the next case what we'll do, we will get rid of the cosine theta and rewrite this entire trigonometric equation as a quadratic equation in terms of sine theta. So let us begin. So to do that, it's a very simple task. It's a simple algebraic task. So if we want to write in terms of cosine theta, so we keep a cosine theta and then we transpose the c from the right hand side to the left hand side, and we are going to transpose b sine theta to the right hand side. So we have negative b sine theta. Now let's square both sides. So we have a cosine theta minus c whole squared. So this will be equals to negative b sine theta whole squared. Now a cosine theta minus c, so that can be easily expanded by using the fact that if we have a minus b whole squared, so that expands to give us a squared plus b squared minus 2ab. Now let's perform. So we have a squared cosine squared theta plus c squared minus 2ac cosine theta. And on the right hand side, we have negative b sine theta squared. So negative b will become positive b squared, and we have sine squared theta multiplied to it. Now we are going to convert the sine squared theta to cosine squared theta, because we know for a fact that sine squared theta plus cosine squared theta, that's equals to 1. That's a very standard identity. So sine squared theta can be also expressed as 1 minus cosine squared theta. So we will now get a squared cosine squared theta. So the left hand side of the expression, nothing needs to be changed because everything is in terms of cosine theta. So we're only going to change b squared sine squared theta into b squared multiplied to 1 minus cosine squared theta. Fine. So that gives us a squared cosine squared theta plus c squared minus 2ac times cosine theta. This will be equals to b squared minus b squared cosine squared theta. So we'll transpose this b squared cosine squared theta and combine it with a squared cosine squared theta on the left hand side. So we get a squared plus b squared, and we're multiplying to it as cosine squared theta. Fine. Then we have negative 2ac times cosine theta, and then we have positive c squared. So we'll transpose this b squared also. We have c squared minus b squared equals to 0. Now what we have here is a standard quadratic equation. So here we started out with a cosine theta plus b sine theta equals to c, and doing some algebraic manipulation as well as trigonometric manipulation, we obtained a new equation which is entirely in terms of cosine theta, and this is a quadratic equation. Now it's given here that alpha and beta are the solutions to the given equation. Alpha and beta are the solutions to a cos theta plus b sine theta equals to c. So that's given to us. And since we are obtaining the equation in terms of cosine theta, so that means the new roots will be cosine alpha and cosine beta are the roots of the quadratic equation. Fine. Now the reason why this fact is very important, because let's say, let me give you a quick idea. So let's say we have alpha and beta are the roots of the standard quadratic equation, which is ax squared plus bx plus c equals to 0. Then the sum of the roots alpha plus beta, that's simply given by the coefficient of x, negative times the coefficient of x, so that's b, over the coefficient of x squared, so that's a. And the product of the roots alpha times beta will be the constant term c divided by the coefficient of x squared, so that's a. Now in our case we have cosine alpha and cosine beta, so immediately we can say that the sum of the roots cosine alpha plus cosine beta, so that will be equals to the coefficient of cosine theta and negative time the coefficient of cosine theta, so we have 2ac over a squared plus b squared, and the product of the roots will be cosine alpha times cosine beta, so that's equals to the constant term, which is c squared minus b squared, divided by the coefficient of cosine squared theta, so that's a squared plus b squared. Now we have obtained the product of the roots. Now our next task will be to obtain the product of cosine alpha and cosine beta. So for that we'll again have to go back to our original equation, which is a cos theta plus b sin theta equals to c. So this time what we'll do, we'll try to convert this equation in terms of sin theta. So that's very simple. So we'll keep b sin theta and we're going to transpose the c to the left hand side, and we will transpose a cosine theta to the right hand side to get negative a cosine theta. Then squaring both sides is going to give us b squared sine squared theta plus c squared minus 2bc times sine theta, and we will have negative a cosine theta squared will become a squared cosine squared theta. So we will replace this cosine squared theta with 1 minus sine squared theta, so we'll get a squared multiplied to it will be 1 minus sine squared theta. So if we rearrange this equation, so we were going to get a squared plus b squared multiplied to it will be sine squared theta. Then we have negative 2bc sine theta, and the constant term will be c squared minus a squared, so this will be equals to 0. Again we have alpha and beta, so this original equation has roots alpha and beta, so the roots of this particular equation will be now sine alpha and sine beta. So these are going to be the roots of the above quadratic equation, which means that the sum of the roots sine alpha plus sine beta, so that's going to be equals to negative times the coefficient of sine theta, so that's negative 2bc, so we'll get positive 2bc over a squared plus b squared, and the product will be sine alpha times sine beta, so that simply equals to c squared minus a squared divided by a squared plus b squared. So now we have the product sine alpha times sine beta as well, and we can finally solve our problem. So we'll begin with part 1 of the problem. So we'll start from the left hand side. So we have cosine of alpha plus beta, and I've already mentioned that this is cosine alpha times cosine beta minus sine alpha times sine beta. We'll substitute the value of cosine alpha cosine beta with c squared minus b squared divided by a squared plus b squared minus, we have sine alpha times sine beta, so that's c squared minus a squared divided by a squared plus b squared. We have a common denominator, so let's combine them. So we have a squared plus b squared. In the numerator we have c squared minus b squared, then we have negative of c squared minus a squared, so we have negative c squared plus a squared. So c squared and c squared gets cancelled, and that leaves us with a squared minus b squared divided by a squared plus b squared. So we have successfully shown that cosine of alpha plus beta is given by a squared minus b squared over a squared plus b squared. Now coming to the second one. So now we have to show that cosine of alpha minus beta is given by this particular expression. So this is simply cosine of alpha times cosine of beta plus sine of alpha times sine of beta. And I'm leaving this as an exercise for you to try out. So if you replace the value of cosine alpha cosine beta with c squared minus b squared over a squared plus b squared, and similarly replace the value of sine alpha sine beta with its respective expression, this is finally going to give us 2c squared minus a squared minus b squared whole divided by a squared plus b squared, hence proof.